The BIOS/UEFI is the underlying system where you can configure how your computer works. It resides in firmware and it boots up before your operating system. Now, historically, the BIOS or basic input output system has been the firmware loaded on lots and lots of desktop and laptop computers. But really, since about 2014, the dominant type of firmware is UEFI. That's the Unified Extensible Firmware Interface. And that's what's shipped with most motherboards today. But BIOS/UEFI or BIOS or UEFI is all really going to mean the same thing within this video course. But specifically, the UEFI communicates more effectively with the operating system than the older BIOS. It allows for mouse-driven firmware-based setup instead of the old school menu-based programs that you'd see in a BIOS. And it includes advanced system diagnosis, except for the worst of errors. It also incorporates something called secure boot mode. And if you're not familiar with secure boot, that prevents digitally unsigned drivers from being loaded into your system. And it helps prevent rootkits from manifesting themselves. It has faster startup times than the traditional BIOS, and it supports more storage drive partitions and works with GPT systems, which we'll talk about later. But whichever you're using, this firmware is loaded on a chip on the motherboard, and it can and should be updated. And this is known as flashing the BIOS. If you flash the BIOS, you are updating that firmware. And there's several ways to update the firmware, but generally you would do it either from within Windows or by using some kind of bootable media like a USB flash drive and boot the system to that. But it's important to flash or update the BIOS to make sure you get the latest in the security updates. Now, this firmware stays resident in the computer after restarts, and that means that it is persistent. You'll hear this term used a lot. It's persistent, meaning it remains there even after you reboot the system. However, individual settings and the actual time and date that you select are stored elsewhere. They're going to be stored in some type of volatile storage. For example, in older systems that have a BIOS, the settings would be stored in CMOS, or complementary metal oxide semiconductor. But in newer UEFI systems, it'll probably be stored in flash memory. But the area where settings are stored can be volatile, and that means that the settings could be lost if the computer is restarted. You won't lose the persistent core of the BIOS or the UEFI itself, but you'll lose those additional settings that are placed in that volatile storage. And that's why your motherboard will come with a lithium battery. The battery retains the individual settings in storage, and it keeps time while the computer is shut down. A common battery that you'll see on motherboards is the CR2032 battery, but you could see others as well. This particular one is a nickel-sized round battery that snaps into the motherboard, and it has a shelf life of anywhere from 2 to 10 years, and that depends on the usage. The more you leave the computer on, the longer the battery lasts. Now, the BIOS or the UEFI is where you would go to do a variety of things. You can set a password, you can change boot options, you can configure the time and date, configure devices, overclock the computer, and much more. Accessing the BIOS or the UEFI must be done before before the operating system boots, because this comes up first. And for PCs and laptops, this could be accomplished by pressing a key on the keyboard. That key could be F2 or it could be the delete key. It depends on the manufacturer of the motherboard or the manufacturer of the system. Some of the settings that you might change and modify include boot options. And this is an important one. It's also known as BIOS boot order or device priority. This setting enables you to select which media will be booted from. And so normally you'd want to set this to storage drive first, like a solid state drive or an NVMe drive. Make sure it boots to that first and is not set to boot to USB flash drives. That would be a security vulnerability. Another one is fan settings. Fan settings can be controlled in the BIOS or UEFI. You have the ability to set whether the case fans or the CPU fans are turned on and at what speed they spin. And then we have passwords. 2 passwords are available in most BIOS and UEFI systems, and those are the user password and the admin password. The user password authenticates a user before it enables the operating system to boot. It's also known as a boot password, but this increases the level of complexity for the user. So a lot of organizations will not use this password. It requires the user to know a second password, and usually the user will have a password or another form of authentication to get into their operating system anyway. However, the administrator password is super important because that authenticates a user into the actual BIOS utility. For a secure system, make sure that you enter in a strong administrator password. In the appendix of videos, I go through an entire build of a system and I actually show some of the settings within the BIOS of that particular system. But right now I'd like to take a look at another system, a Supermicro server, and take a look at the BIOS on that. So we'll go to a new browser here. And what I'm going to do is I'm going to connect to this system via IPMI, which is the Intelligent Platform Management Interface. And this allows us to take control of that server, even if the server is off. And so we're going to take control of it now and actually boot it up and enter the BIOS. The IP for this server is 10.41.0.15. And even though the computer is off, as long as it's plugged in, the IPMI port will work. And that firmware will be functioning, and we can actually log into the system. So I'm going to do that now and type in my password here. And we're in. And from here, we can view the server health and all the other good stuff about that system that relates to the BIOS. We can even remotely control the system, and that's what I want to do here. So I'm going to go to Remote Control, and I'm going to select iKVM HTML5 and start that up. That's going to open up a console where we can control this system. Now, the system is off right now, but I'm going to go to Power Control and turn it on. Set power on. That's going to boot up the system. And once it does, we'll need to press the delete key to actually get into the BIOS. I'm going to start doing that now and wait for the system to boot and get into that BIOS. And we'll speed through the video while that's happening here. And so I was pressing the delete key to get into the BIOS of the system. So a pretty cool system that we have here. This is actually a Supermicro motherboard, and it gives you the ability to remotely control that system. So you don't even have to go to the server. You can boot it up, shut it down, do everything you need to do, and see and access what's on the screen directly from the built-in console within this program, all through the browser. So this is what you would see on the screen of the server, and it's asking for the password to the BIOS. This is the administrator password, and if As I mentioned, you want that to be a strong password, so I'm going to type that in now. And we're in. So this is the BIOS for this particular system. Make this a little bigger. And you can see the main information here, system date, system time. It's a super micro board. And if we look over here at the boot menu, and this is all keyboard driven, by the way, you can see the boot order priorities. And you can see here that we actually have a little bit of a security issue. It's set to USB first and hard drive second. We don't want that. We should modify that to hard drive first. And so, for example, we could go to the first one and modify the order here to hard disk, Ubuntu, and that's actually what's installed here. And now it should boot to that and not to a USB drive. Also, we can change security like the administrator password. We already have one, but if we didn't, we'd want to set that up. You also have that secure boot option here, which I'm not using right now because I'm working with Ubuntu on this. But if I was working with Windows, I would most likely use secure boot. Escape out of here and check our boot settings. Everything looks good. I'm going to save these changes and reset the BIOS. That information will be saved to volatile storage. We'll press enter for that and say yes. And that'll save that BIOS configuration and reboot the system and reboot us into Ubuntu. One last thing you should know within this topic is something called the POST. POST stands for Power On Self-Test. And this is essentially a piece of code that the BIOS or the UEFI will run to find out all kinds of stuff about the computer, like what type of CPU, what RAM is in there, and so on and so on. It also identifies any other devices on the motherboard, and it identifies which devices are available to boot from. If the BIOS or the UEFI finds any types of system problems, it will report those to the POST, to the Power On Self-Test. And this could be shown either as on-screen display codes or audibly as beep codes, or possibly an integrated error code readout on the motherboard itself, a digital 2-number readout, which would be hexadecimal, anywhere from 00 to FF. And you'd see that little digital display right on the motherboard. The exact code that you get will depend on the type of BIOS that's used. Your motherboard should come with documentation about any possible BIOS or UEFI error codes, and you can usually download this from the manufacturer's website. You just need to know the model number of the board. Okay, to review, you should know what the BIOS UEFI is and how it works in conjunction with volatile storage like CMOS or flash, and what the lithium battery does and how it retains those settings in the flash or CMOS, and also know what the POST is, Power On Self-Test. Know those for the exam. And that's about it for this video.